All right. Well, thank you for your flexibility in meeting online via Zoom today. And let's go ahead and take a look at today's content here. Okay, so we have today we are covering environments and scoping rules. And so this is related reading. A little bit comes from, most of it comes from the environments chapter. And I've, some of it, this is a long chapter. So it's, pared down. And then a little bit comes from the section on binding basics, and a little bit comes from lexical scoping. And these are all from Hadley Wickham's book. And I have straight just taken his illustrations, which are very good, to kind of illustrate some of these ideas here. So these illustrations come directly from his textbook. Okay, so let's see. When we're talking about environments and scoping, the idea is how does R search for values, and where does it find the values, and where do these when it looks for the names and the objects and things like that, how does it work, right? And so you guys are familiar with the global environment. So basically all the objects, all the values that you store, when you store them, you're associating them with a name, and those names exist in your workspace. We also call that the global environment. And then if you write a function, when the function is running, it creates something called a local environment. And we mentioned this when we were talking about functions, but we said, any objects that are created during the running of the function, those only exist inside the function. And those values don't appear in the global environment. Okay. And then, and if we have a situation where there are different objects that have the same name, okay, then objects in the local environment will take precedence over objects in the global environment. So if we have two objects called X, and the function, and inside the function it asks for a value X, it's going to search for the value X inside the local environment before it looks for it's going to look for X in the local environment, and it's going to find it in the local environment, and it's going to ignore the X that exists in the global environment. And so that means we say the global environment object, the global object, is masked by the local object with the same name, right? So the object name within the function will reference the local object instead of the global one. So, an important idea is how objects get named, or technically how names and objects get binded, or names get binded to an object, okay? So if we write something like this, X is this vector 1, 2, 3, the way we think about this oftentimes is we say, oh, we're just making an object called X, and it has the values 1, 2, 3, okay? What's technically going on is that the assignment operator, okay, that's the little arrow, and I guess the equal sign also does this, will bind the name X to the vector 1, 2, 3, all right? And so what's going on is inside your computer has memory, right? And it is creating this object with the values 1, 2, 3 somewhere in memory, okay? And that object has an address, memory address location. And then the name X is a reference to that location in memory. So so the name or the variable is a reference or pointer to that vector, and X points to the memory location that contains this value 1, 2, 3. If we do something like this, okay, so we create 1, 2, 3, and then we bind the name X to it. Then we bind Y to X, and then we bind Z to 1, 2, 3, this thing 1, 2, 3. What's the difference between Y and Z? Okay. The difference is that X and Y are pointing to the same object, this object in memory, and then Z is pointing to a different object, a different copy, or a different object, which happens to contain the values 1, 2, 3. So as we are going through the code, again, this line of code creates this object that contains 1, 2, 3 at this location in memory. And then here's another copy, right? And so it's kind of like, I guess you purchase a textbook, all right? And then and you let your friend Y also use the same textbook, all right? So if we say, hey, give me your textbook, they're both people will be looking at the same physical object, okay? And then person Z over here gets basically the same textbook, but it's like a new copy of it, right? This a new copy of it. So these are two different objects. These are two different objects. So Y is looking at the same object that X is looking at, same physical object. Z is looking at a different physical object that happens to contain the same values. What R does is that if you modify an object, okay, then R creates a copy, okay? R does this thing called copy on modify. So here, we've created this object that contains the values 1, 2, 3, and we bind the name X to that object. And then Y points to the same object, the same kind of object in memory. And then here, I say, you know what, change the third value in Y to the number 4. We're going to take 4 and we're going to put it inside the third location in Y. And so what happens here when R sees this operation, R is going to create a copy. Okay, it's going to take this object in memory and it's going to create a new object in memory. It creates a copy, and then it changes that third value to the number 4. Okay, and so at this point in time, at the second line of code, Y and X are pointing to the same object. But then when the third line gets executed, R recognizes that something is happening, so it creates a copy. Okay, so X still points to this original object 1, 2, 3, and so when we call for X later, it still has 1, 2, 3. But then internally, Y is pointing to a new object now that is now going to contain 1, 2, 4. All right, and so that's how R operates. It only creates a copy when you ask for it to modify something. And okay, so what we're going to look at now is we're going to start to learn how scoping rules, okay, scoping works. And basically scoping is how do we find the value associated with a name, right? So assignment binds names to values. Scoping retrieves values associated with names, okay? So the scope of a variable is kind of the region of the code where the variable is defined. And most of the scoping rules kind of make sense, I think. So here we've got Y is associated with the value 1 in the global environment. And then G is a function that's created in the global environment. And what G will do is it takes the value X, and inside G, we create an object called Y that takes the value 2, and then we're going to return X plus Y. So when we execute this code, what is this function going to return? So we say G on 3. So what value will this function return if we run that? It'll return the value 5, right? Because we put 3 into X, And then when it's running, it's going to say, okay, 3 plus y. And then when it looks for y, it's going to look inside the local environment and it's going to find the value 2. Okay. It's not going to take the value 1 from the global environment. It's going to take the value 2 from the local environment, 3 plus 2, and it gives us the value 5. Okay. So again, yeah, when we look for 3, and when we look for y, it finds the value 2 in the local environment. So basically, any kind of object that's defined inside the function will mask values that exist outside the function, right? And that's effectively probably the most most important rule that you need to remember in R. And I would say if a function is behaving in a way that you are not expecting, it's probably because you've done something wrong with this kind of setup, where you are looking for a value and the value already exists inside the function, or it doesn't exist in the function, so it searches outside the function, and something is going on there. Okay, a lot of times these kinds of things will not throw errors, but they will return values. It's just that maybe the value isn't what you were expecting. Okay, and so that's an important thing when you are writing code and debugging. The goal isn't just that it's not throwing errors, but it's that it's returning values that you are expecting it to return. So anytime you write some code and you test it out, you should have a simple test case where you know what the numbers should be when it's done executing. So you should be like, okay, if I put in the number 3, I'm expecting the value 5, and then you execute it, and do you indeed get the value 5? If you did, then great. Okay. All right, let me go ahead and give you your first view quiz answer for today. Today's first view quiz answer is the letter A. A as in apple. A as in apple is your first view quiz answer. Okay. All right, so what happens here? All right, so kind of the main scoping rule is we call this lexical scoping. And if R can't find a variable in the function body's scope, it's going to look for it in the next higher scope. Okay, and so in general, it's not a good idea to refer to objects. When you write your function code, you want to only refer to values that exist inside the function, but sometimes you don't. And if that happens, then R is going to look for it in the higher scope. So here, y takes the value 1 in the global environment. And inside this function, it's a function of x, and the value that it's going to return is going to be x plus y. And so here, when we ask R to execute f of 3, x gets the value 3, and then it doesn't find the value y inside the local environment, the local scope, and so it's going to search for y in the higher scope, which is going to be the global environment, and it's going to find the value 1, and it's going to return the value 4 here, right? So I don't think this is a surprise, but that's how it's going to work there. Okay, and again, these are very, very simple examples, but one, you have the name, the value of the named object exists inside the function, and it's going to find that. And over here, the value of the named object doesn't exist inside the function, so it searches the global environment. Okay, and these are kind of the two simplest cases that I can kind of create here. And again, when you encounter your functions behaving a little bit funny, it's probably because you're thinking of one and it's actually the other. But let's keep going, and we're going to kind of do a whole bunch of different cases, just because as things get bigger, things can get weirder too. Okay. All right. So again, variables defined within a scope only exist in that scope and only for that duration of the scope. So this is most frequently applied to functions that are written. If variables exist within the same name outside the scope, those are separate and they don't interact with the variables inside the scope and they are not overwritten. So, when you execute a function is its own separate environment that only communicates to the outside world via arguments going into it during when it's called, and then the object being returned when it's going out. Okay, and so if you were to write this command rm list equals ls, which is used to delete everything in the global environment, but if you write that inside a function, which by the way you should never do, but if you were to write that inside the function, then that will only delete all the objects that have been defined inside the function. So if you do that inside the function, it'll delete everything inside the function, and that's it. So basically all the argument names that come into the function, those get defined as soon as the function gets called. But if your line of code says, remove list equals ls, then all those argument values that came in, those will get deleted. But it's only going to affect everything inside that function scope. The exception is the superassignment operator, this double arrow operator, which will search the higher scope and the global environment. And I'm going to kind of show it to you. But again, we consider this to be a dangerous operator, and I don't want you to use it. So, and I hesitate to kind of teach this to you, but I guess for completeness, I show it to you and I show you a few examples of how it works. But, for your homework, I really don't want you to use this. Okay. And I I strongly emphasize. So, sometimes for homework 3 and homework 4, there will be situations where it's going to be tempting to use the superassignment operator, but don't use it. Okay. Figure out a way to do your code without using the superassignment operator, right? Sometimes you're like, oh, it would just be so easy if I used superassignment, but using superassignment just makes debugging your code later much harder. So don't use the superassignment operator. Okay, so let's look at this situation where what's happening here. Okay, so these are little quiz question things, and you can answer the questions if you want or you don't. Okay, have to. So we get X, Y, Z. They each take on the value 1 in the global environment. And then we have a function, and then F is defined in the global environment. And then we create a function G inside the function F. And that might feel weird, defining a function inside a function, but you're allowed to do that. And there are cases where it's useful to do something like that. So within F, we Y gets the value 2. And then within F, we create a function G. And inside G, we Z gets the value 3. And then G returns the value X plus Y plus Z. And then when we execute F returns what it calls G, and it returns that. So if I call F, what value is it going to return? What do you guys think? Okay, so people are asking 6 question mark. I think 6. Okay, and then what about what are the values X, Y, and Z in the global environment? Okay, so those are all still 1. Yeah. Okay. So we're someone said, well, maybe it'll return an error. So inside, so when we call F, right? So we call F. So we run the line X, Y, Z. We call F. And when F executes, it assigns 2 to Y, and then it returns, and then it says return G. So then now it's going to execute G. And when it executes G, it's going to assign 3 to Z, and then it's searches for X, doesn't find it inside G, doesn't find it inside F. So it takes 1 from the global environment, searches for Y, doesn't find it inside G, finds it inside Y, or it finds it inside F and takes the value 2. And then when it says add Z, it finds Z right here, which takes the value 3. And so indeed, we get the value 6, and X, Y, Z and the global environment all have the values 1. Okay, so good job there. All right, let's talk a little bit about this data structure environments. Environments are basically how we power scoping, and the job of the environment is to basically bind a set of names to a set of values. And so you can think of an environment as a bag of names, and we use it a bag because there's no order. There's no order to the names. So everything has to have a name. Okay, you can't refer to something and say, hey, I want the third object. Okay, because if you think about like a bag or your purse or your backpack or something, and I say, hey, I want the third object, not the fourth object, but I want the third object. And it's confusing because there's no order to items in a bag. So you have to give things a name, right? I want, the red pen. I want the object A or something like that. And so here, this box is the environment. And within this, within the environment, we have names, and they all point to different objects that exist in memory. So we have, the character string A that exists in memory, and the value 2.3, and this vector that has the values 1, 2, 3. These are objects in memory, and the names point to those objects. Okay, and this is E is an environment. This is the kind of in the environment there. Environments themselves are objects. Okay, and you kind of interact with environments similar to the way you interact with lists, in that you can use the $sign or you can use the double square bracket. Okay, but again, they are not in order, so you cannot reference something and say I want the first item. So E double square bracket 1 will return an error if it's an environment. The ls function and ls str list structure, or ls basically contents, is looking at basically what are the names of all the objects inside the environment, and ls str gives you a little bit more details of each of those things. So A is a logical value with the value false, character, numeric, integer, vectors, and things like that. So not just the names, but also a little bit of their contents. Difference between environments and lists. Okay, so single square bracket doesn't work. Setting an object to null doesn't remove the object. Okay, so here if I do null to D, it still exists. All right, D just now takes on the null value. If you want to remove an object from an environment, you have to use RM. Okay, and so if we called RM on D without this environment here, it would apply it to the global environment. So it would remove an object called D in the global environment. And we have ls now only contains ABC, no object D there. Every environment has a parent environment, and that is shown with this little blue circle. And this is how lexical scoping works, is that if R can't find the name in the current environment, then it finds the parent, looks in the parent environment, searches for the name, and it keeps going up the chain of environments until it gets all the way to the very top, and the very top has no parent, and that's the empty environment. Okay, so that is the that's at the very, very, very top is the empty environment, that and that's the only environment that doesn't have a parent. So so there's kind of, these environments are the ones that you kind of need to know about. So the global environment, this is your regular workspace that you interact with. And the parent, and this is a little bit weird, the parent of the global environment is any package that you attach to a library. Okay, so the most recent package that you call library. So if you call library ggplot, or ggplot2, then that will become the parent of your current global environment. Okay. Further up the ladder of environments will be the base environment. The base environment is the environment of the base package, and that contains kind of all of the base functionality that that R uses to operate. So things like the function C, right? The function C that we use to create or combine vectors and create vectors, that's inside the base environment. Things like oh, now I forget. You know, stuff to like create a matrix, that's going to be in the base environment. And then, you know, there's a few other packages like the stats package that contains functions like SD to find the standard deviation and stuff like that. I can't remember if mean is a base function or a stats function. I think it's base, but I don't remember 100%. Okay. The empty environment is the ultimate ancestor of all environments. And that's the only environment without a parent. Okay. And then environment is your current environment. You have something called the search path. And this lists all of the environments in order. So you can see kind of, you know, your global environment is first in the search path. And then it lists all of the kind of the other packages that serve as kind of the chain of parents. So because I've knit these notes, package knitter gets loaded. Okay, if you were to type search into R right now, it probably won't include package knitter. So here is, so if I type in search here. So here I've got global environment. Oh, okay, loads the RStudio tools package. Okay, but then it has package stats, package graphics, package GR devices, utils, datasets, methods, auto loads, org rlib. I don't know what that is. Okay, and then package base. All right, so it's a little bit different. A couple things that are a tiny bit different. But overall, basically all the different packages that get loaded. And so, you know, probably most of the things that you're accustomed to, all the functions that you are accustomed to using are in the base package and either stats or utils. So stats also contains functions like LM to create linear models and stuff like that. And so this is kind of how the search path is visualized. So you have the global environment, and then all of the libraries that you've loaded or that automatically get loaded when you start up are including package stats and stuff like that until you have the base environment. And then the base environment's parent is the empty environment, and the empty environment has no parent. All right, let me give you your next view quiz answer, which is the letter E, E as in elephant. E as in elephant is your second view quiz answer, E.
Excuse me?
Yeah.
What was the first view quiz answer again?
All right, I'll enter it into the chat. Okay.
Thank you very much.
Okay, and then so if you load a new package library, package with library, that package environment is inserted between the global environment and the package that was previously at the top. So over here, if we have package ABC and then we load a new package library D, then it gets inserted here, and then the parent of the global environment is now D. Okay, the parent of D is C, and then C's parent is B, going to A up to base. And again, this is all kind of shown in the search path, showing you all of the packages that get loaded. Most of the time when we have kind of environments and stuff and we have to think about them, those are it happens when we execute functions, right? So what's important to note are basically you have 4 environments associated with a function. You have the enclosing environment, the binding environment, the execution environment, and the calling environment. The enclosing environment is the environment where the function is created. Every function has only one enclosing environment. As far as the binding, execution, and calling environments, you might have 0, 1, or multiple of those things, okay? In most examples, it's straightforward, but if you ever get into package creation, like you're going to create a new package, then you have to kind of keep track and think about some of these other things. And the textbook Advanced R gets into some of the details and the distinctions, which would be important if you were to say you wanted to create your own package and publish it to CRAN or something like that. Okay, the binding environment is basically where the name is bound. Okay, so binding a function to a name with the assignment operator defines a binding environment. And then when you execute the function, when you call the function, it creates an execution environment. That's kind of the local environment that contains all of the variables during the execution of the function. And the execution environment is associated with a calling environment, which tells you where the function was called. So if you call the function from the global environment, then the global environment is the calling function. But if you call the function inside another function, then the function from which you called the other function is the calling environment. So sometimes, right, while inside your code, when you're executing a function, you might use another function, right? Like inside your function, you might call the function mean or standard deviation. That's like a very common thing. So technically that function mean, it is being called from inside another function. So it has a different calling environment. Okay, so here, this is what I wrote. When a function is created, it gains a reference to the environment from where it was made. This is the enclosing environment, and that's how we do lexical scoping. When you name a function, the environment where the name exists is the binding environment, all right? And so most of the time, when you're like writing functions, the enclosing environment and the binding environment is going to be the same. And this is going to be the case for like, 90 something % of your cases. Okay. Again, there's a difference when you write a package and the namespace and the enclosing, those things differ. We have a question about super assignment inside a function, and don't worry, we'll cover that as the lecture goes on. Okay, so here's about as simple as a function as we can have, right? F is the function. F is a function. It takes in the argument x, and it adds x plus y. Okay, and so we ask, hey, where's the environment of F? Okay, environment of F says, oh, F is created inside the global environment. Okay, that's the enclosing environment. Okay, inside the global environment, we also have a variable, a name y, that points to the an object with the value 1. Okay, so this is kind of what our picture looks like. Inside the global environment, we have two objects, or two names, F and Y. Y points to 1, and F points to a function. And this function's enclosing environment is the global environment. That's what this little arrow is pointing to. Okay. In the search path, we saw that the parent environment of a package varies based on what other packages have been loaded. And so, what will happen? Does this mean that packages will find different functions if packages are loaded in a different order, right? So if you have some function mean and it's pointing, or standard deviation, right? So standard deviation could exist in the package stats, but somebody else could create another package with the function SD and things like that. So how do we find these things, right? So so if we look at the function standard deviation, if you look at the code inside the function standard deviation, the function standard deviation is the square root of the variance. Okay. And then, there's other stuff. Basically, if it's in vector or if it's a factor or something, then just take x. Otherwise, then take x and make it a double and things like that. The standard deviation is defined in terms of the variance function. And so how does R make sure that the standard deviation function is not affected by any other function? Like, let's say I created a function called variance var in the global environment or something else in the search path. How do we know that this standard deviation function isn't suddenly going to break if I create, right? Like inside here, so inside R, let's say, I say, okay, here is, we're going to make a vector. Okay, just 1 through 10. Okay, so here's X. And if I want standard deviation of X, I got this, right? And if I say, hey, what's the definition of standard deviation? It's defined as the function variance, right? And so here I could create, I could ask what's the variance of X, but I could also create a function called variance. And the variance is going to, this is just going to return 5, right? So I could say, what's the variance of X now? It's going to say 5. And, but if I ask what's the standard deviation of X, it doesn't break. Standard deviation of X is still returning 9.166, right? So how does this standard deviation function, which is defined in terms of the variance, not to use this function var that I created in the global environment, right? Because if I ask what's the variance of X, it's going to give me the wrong answer, 5. Right? I would have to do something like, I think, was it stats? Okay, so if I refer to, function package stats variance, I can get 9.1667. And so that will work. Okay, but the one that's inside my global environment here, right? So this is how namespaces work. Okay, namespaces will say, hey, you know what? This is where you're going to search for these things. So the distinction between the enclosing environment and the binding environment is important for when you have excuse me, package names. Let me get a sip of water here. Okay, so to ensure that packages will work the same way, regardless of what packages are attached by the user, when you create a package, it requires an internal environment called the namespace in which the package functions are defined. And so every function in a package is associated with a pair of environments. That is the package environment and the namespace environment. And therefore, the package environment is the external interface to the package. This is the environment which the R user uses to find a function, and its parent is determined by the search path, right? So if you load packages in a different order, the package environment goes into different orders and things like that. And therefore, when you load a package later or earlier, and you type in this name of the package, name of the function, it's going to go in the order of the search path, okay? And you can use the double colon operator to access a function directly from the package environment, regardless of the search path, okay? So if you use base : mean, it's always going to return to the mean function in the base package, whereas mosaic : mean, so there's a function package called mosaic, and it has a function called mean. And when you call mean on that, it's going to find the mean function in the mosaic package, okay? And so this allows you to kind of find functions, even if they're masked by other packages, okay? Whereas the namespace, that's the internal interface, and that's going to show you where it's going to search for the names and stuff, okay? So the package environment controls how we find the function. The namespace controls how the function inside that package will find its variables. So when we have standard deviation over here, and it's searching for the function called variance, okay, it knows to only search from its namespace. It's not going to search, it's not going to look for variance in the global environment. All right, and that's how I can get away with creating just some silly function variance in the global environment that gives me the wrong answer. But the standard deviation function still works. And that's because it's using its namespace environment to find It's variables. All right. So I hope that distinction is okay as far as the distinction between the binding environments and whatnot. Okay, I gotta keep going here. Execution environments. So anytime a function is called, new environment's created, and then again, this disappears once it's done. So let's look at this function. We're gonna have create a function called h. Inside h, a gets the value 2, and then we're gonna return x plus a, and then we're gonna call the function h. We give it the argument 1, and we're gonna assign that result to y. So this is what it's gonna look like, okay? This is the global environment, okay? When we call h with the value 1, what it's doing, okay, is that, so here's the name, h points to this function that exists. When x gets executed, it creates this thing, okay? This is the execution environment. Within the execution environment, we get the value 1 gets associated with the name x, right? As soon as you type this in, this implicitly associates the name x with the value 1. So this creates an execution environment. X is associated with the value 1, okay? This is the execution environment. The parent of the execution environment is going to point to the, the function environment itself, and then the function, and then that points to the global environment here. Okay, now we're going to, as the function runs, right? So that very first line of code associates the number 1 with x. That just happens when you call it. We're going to now associate the name a with the value 2. A gets bound to the value 2. Then we return x plus a. So that x plus a is going to be 3. 3 gets returned. The function returns, okay, the value 3. This execution environment now is done. Okay, it's gone. It's returned the value 3. Okay, and we do a final thing where that value 3 gets the name y gets bound to the value 3. So the function completes by returning the value 3, and then that execution environment goes away. When you call a function, it creates an execution environment. The execution environment has two parent environments, sorry. The enclosing environment where the function is created, and the calling environment where the function is called. If you create a function in the global environment and then call the function from the global environment, then the calling and the enclosing environment are the same. But sometimes you call a function inside from inside another function, and then in that case, the environment rules are different. R's normal scoping rules will always use the enclosing environment. So if the function is looking for values, it's going to look in the enclosing environment. But R also supports something called dynamic scoping, where you can look for values in the closing environment, in the calling environment, and that's achieved using the function get. So, so let's look at a couple examples. Before I run out of time, let me give you your third view quiz answer. Third view quiz answer is the letter B. B as in bear. B as in bear. B. Okay, so let's look at this, okay? So here we define H inside of F, okay? H is a function, it's defined inside of F. When we execute F, it returns, it's gonna do X and associate X and Y, create H, and then it returns H. So when I call F, what is this gonna return? X has 0 and Y has 10 in the global environment. Inside F, X gets 2, Y has 100, and inside H, X gets 50, and we're gonna return X plus Y. So what do you think we're gonna get? 150, 102, or 60, or I don't know. What do you think? Okay, so here when we call H, it's gonna look for X plus Y. X has the value 50. It's gonna search for Y. Y is in enclosing environment. I mean, the enclosing environment of H is F. It's gonna find Y inside F. It's gonna return 150 here. Okay, so the details of this is given here. So this returns 150. Okay, what about over here? G is defined inside the global environment. H is defined inside the global environment. So if I call H, what is this going to return? We're going to get X is 3, and we do X plus Y. It searches for Y where? In the global environment. So Y is going to get the value 10. And so what is H going to return? H is going to return 13. Okay. What about G? If I call G, I get X is 2, Y is 100, and then we call H. All right. So what G will return is G returns H. Executes H and returns that. Well, when we call H, it's going to say, okay, X gets 3 and return X plus Y. Where does it search for the Y? The default scoping rules is that it's going to search for Y in its enclosing environment. The enclosing environment of H is the global environment. So X plus Y is also going to do 3 plus 10 and return 13. So both H is going to return 13 and G is going to return 13. So, so H returns 13. And then when we call G, it also returns 13. All of my explanations are detailed out here, and I'm kind of skipping over this a little bit quickly because I expect you guys to go through this in your own time and read through the notes on your own time here as well. But all of the details are written out. H returns 13 and G returns 13. If you want to do dynamic scoping, then you use this function called get, okay? And get will search the calling environment, all right? So when I execute H here, we're going to get X is 3 and Y, it finds the parent scope and it's going to do 13. When I call G, G returns H, okay? But this time when H gets executed, it's going to find X is 3 and it's going to search the parent frame, in this case, the calling environment, and Y is going to get 100. And so G will return 103. So H will return 13 and G will return 103. So that's the difference between your regular scoping rules where you'll both H and G return 13. And over here, H and G, this H will find the calling environment and search for values there, and you will get 103. Okay, this last section's on super assignment, and I'm not gonna, I will allow you to go through it on your own time because we're out of time here. But this is where we are modifying things in the global environment, okay? And again, super assignment, you should avoid this. But here's a quick example. X is 1, Y is 1, Z is 1 in the global environment. Inside function F, we're going to do super assignment 3 to Y, and this is going to assign, and it's going to modify the value of Y in the global environment here. And so when I call F, it returns Y, it takes the value 3, and then X, Y, and Z in the global environment. Now Y takes on the value 3, okay? And I've got a few more slides showing examples of how the super assignment operator works. And I wrote comments kind of explaining what each of these operations are doing. So go through this, and I do want you to understand how super assignment works. Just I don't want you to use super assignment in your coding assignments. Okay. All right. We'll go ahead and end here for today, and have a great rest of your day. And we will see you all on Wednesday. I will have office hours today at 11:30. So if you're coming to office hours, I'll see you in a bit.